Okay, hello everyone. This is lesson 2.6, solving absolute value equations. In lesson 2.6 and 2.7, we will be dealing with absolute value. And remember, with absolute value, you can have two possible scenarios. So for example here, where it says to solve the equation of the absolute value of x equals 6, we're trying to figure out what numbers would actually make this equation true. What numbers could we replace x with that we could take the absolute value of and it will equal 6. Remember, the absolute value means the distance away from 0. So we have two cases or two possible answers for this. Case 1, we just drop the absolute value symbols off and solve the equation. In this case, the equation is already solved, x equals 6. That would be one of our answers. Case 2, remember, if we take the absolute value of a negative 6, we would also get 6. So case 2, I call my negative case. Again, we drop the absolute value symbols off, but on whatever number that's on the right-hand side of the equal sign, we will change the sign of it. So we'll make it negative in this case. So my answers would be 6 and negative 6. And remember, you can check your answers by placing them back into the original problem. So if I replace x with 6, the absolute value of 6 is 6. If I replace x with negative 6, the absolute value of negative 6 is also equal to 6. So you'll have two possible answers with each of your absolute value equations or inequalities. Okay, so let's look at this one. It says solve the absolute value of 6 plus 2n equals 4. Again, we're going to have case 1 and case 2. Case 1, we simply drop the absolute value symbols off, and then we solve the equation. So the first thing we would need to do is subtract 6 from each side, and then divide by 2. So we find out that n could be equal to negative 1. Case 2, we drop the absolute value symbols off, leave everything like it is that was in the absolute value. On the right-hand side, we'll change the sign of this 4 and make it negative 4. And then we'll solve the equation. Subtract 6. So we get 2n equals negative 10, and then divide by 2. So therefore n equals negative 5. So negative 1 or negative 5 would be our answers. Okay. All right, so again, case 1, you leave it like it is, and when you're solving these, you want to make sure that the absolute value is isolated on one side of the equal sign. So if there was anything else that was outside of the absolute value symbols on that left-hand side, we would move it to the right-hand side first, and then perform our case 1 and case 2. Okay, so for example, with this one, we have 2x minus 6 equals 4. The absolute value of 2x minus 6 equals 4. Since this minus 6 is not inside my absolute value symbols, the first thing that I would want to do is move it to the other side of the equal sign. And that'll give me the absolute value of 2x equals 10. Now would be the time that we would use our case 1 and our case 2 once we get that absolute value symbol isolated. So case 1, we'll have 2x equals 10. Solve that by dividing both sides by 2. We get x equals 5. Case 2, we would have 2x equals negative 10. Again, divide both sides by 2, and we get x equals negative 5. So our answers will be 5 and negative 5. And again, you can plug those in, and it would still work. If I plug 5 in, 2 times 5 is 10. The absolute value of 10 is 10, and 10 minus 6 equals 4. So you can always plug those back in to check your solutions. Okay, but the key here, make sure that the absolute value symbol is isolated on one side of the equal sign. Okay. Okay, let's look at this example. We have the absolute value of 3z minus 2 equals 8. So the first thing that we would have to do is to move this 8 to the other side of the equal sign. So that gives us the absolute value of 3z minus 2 equals negative 7 when I subtract 8. 1 minus 8 is negative 7. Now remember, every time we take the absolute value of something, we end up with a positive answer. So therefore, if you have this equation, this setup, where we have the absolute value of whatever this is, and it says that it's equal to a negative number, that is not possible because anytime we take the absolute value of something, we get a positive answer. So in this case, it would be no solution. We cannot take the absolute value of something and come out with a positive result. So when you get to this line right here, if you have the absolute value of whatever this is on this left-hand side, and it states that it's equal to a number less than 0, that's impossible. Your answer will be no solution. An absolute value can never be equal to a negative number. Okay. All right. Now this one, we have the absolute value of 9y plus 1 equals 6y, the absolute value of 6y plus 4. So we have absolute value symbols on each side of the equal sign. Well, you still have your case 1 and your case 2, and you work this the same way as we worked the previous problems. Case 1, we want to drop the absolute value symbols off of each side, and we would go through and solve the equation. So remember, we have these y's on each side of the equal sign, so we want to get those y's combined. So I'm going to subtract 6y from each side. That will give us 3y plus 1 equals 4. Then we want to subtract 1 from each side to get the numbers to the right-hand side of the equation. 3y equals 3. Divide by 3, and y equals 1. So that's one of our answers. Case 2, it's the same thing. We're going to leave the left-hand side like it is, but the right-hand side we need to make negative. So I'll place a negative outside a set of parentheses there. And remember, if you have a negative outside of a set of parentheses like that, you're going to have to distribute that negative into the parentheses to each one of those. So that gives us 9y plus 1 equals negative 6y minus 4. And then we'll go through and solve. So we're going to add 6y to each side. That gives us 15y plus 1 equals negative 4. Subtract 1 from each side. That gives us 15y equals negative 5. Divide each side by 15. And we can reduce that fraction. Both 5 will go into both of those. So that gives us y equals negative 1/3. So our answers would be 1 and negative 1/3. Okay.